Hey, why did the picture go to jail? Because it was framed, of course. Ha. Anyways, we're going to be looking at one-step equations. You guys have looked at these in the past, so this is a review lesson, and we're doing it to make sure that we're really confident in some of the basics before we move on to the advanced equation. Agenda, we're going to review some key terms and example problems, but this is what you're supposed to be able to do at the end of the unit, or at the end of this lesson. I can solve one-step equations using either multiplication, addition, subtraction, or division. All right, let's get started. Some key terms that I want us to be aware of include expressions, and equations. So expression and equation. And I'll capitalize both my E's here. Equation. Now we know the difference between these. An expression is something just like what I'm going to underline in green right here. This is like an expression, and this is an expression on the right. But the whole thing that I'm circling is an equation because there's an equal sign. Okay, when solving equations, the goal is to find the value of the variable. In this case, the variable is the letter x. You can do this by performing the opposite operation of the equation. So in this example that I gave, negative 2x equals negative 8, the opposite of what's going on to the x is what we would do. So we first have to determine what's going on to the x. Well, obviously multiplication. So because negative 2 is being multiplied by x, we divide both sides by negative 2. And now here's where I want us to think about some of these key words. In expressions, when we were combining like terms, we didn't have to worry about doing anything to both sides because there was only one side. There was no equal sign. But in equations, equations are like balance beams. In other words, if you think about it like this, you've got this toy on the playground that kids like to play on. It's like a fulcrum in the middle. It's like a teeter-totter, right? And you'll have one kid on one side and one kid on the other side. And if they're about the equal weight and the equal distance from the center, then they're balanced, right? Well, if another kid was to come jump on this side and nobody jumped on the left-hand side, obviously this side would go down and this side would go up. Right? Well, to keep it balanced, we have to do exactly the same thing to both sides of an equation. So if we add a kid, we have to add a kid over here too to keep it balanced. And that's what we're doing. So the reason we divide it by negative 2 is look what happens over here. What's any number divided by itself? Well, it's 1, of course. So these cancel out, and 1 times x is just x. So by dividing by negative 2, that goes away, and you're left with just x. And this, of course, is 4. Now, I know this must be right because if I was to plug in 4 for the variable here, negative 2 times 4 is indeed negative 8. So I get a true statement out of it. So we're going to go over a few more examples. I'm going to kind of line out some steps I want you to do for this. All right, on all these on all the problems in your worksheets, you have to show all the steps that you're doing. In this case, it's one step, hence the word one-step equation. So the first thing to do is to determine what's going on to x, or going on to the variable. In other words, is there something being multiplied by the variable, subtracted, added, what's going on? In this case, something's being subtracted. Second step is do the opposite operation. Do the opposite operation to both sides of the equation. To both sides of the equation. Oops, and I can't seem to write correctly. Okay, to both sides of the equation. So I'm going to bang out these examples real fast so we don't take too much time. So in this case, we were subtracting 15, so I'm going to add 15 to both sides of the equation. Okay, and I'm going to write it out like this. This is the kind of writing I want to see in your work, or I won't be giving you credit. So negative 15 plus 15 is 0, so these cancel out, and I'm left with just x minus 0 equals 47, but x minus 0 is just x, so I can say that x equals 47. That's as simple as this as it is. You did the opposite, and I figured out that x was 47. But I want to see your work written like this for credit, okay? No exceptions. This problem right here, the first step, determine what's going on to x. In this case, there's a 16 being added to x. So I've got to do the opposite, or subtract 16 from both sides of the equation. In this case, 16 minus 16 is 0 plus x, because I didn't do anything to the plus x, so it comes down, equals 34 minus 16, which is, I think it's 18. Yeah, it's 18. So in this case, x must equal 18, and that makes sense, because if we were to put 18 in the place of x here, 16 plus 18 is indeed 34. So everything we're doing is making sense as we go. When you get to division, same thing applies. So this is x divided by 9 equals -8. What's the opposite of division? Well, it's multiplication. So I'm going to multiply both sides of this equation, which I'm rewriting right now. I'm going to multiply both sides of it by 9, okay? Now look what happens. This is why 9 gets rid of 9 here. If I was to turn this 9 into a fraction and multiply, you may remember from a long time ago that when you're multiplying fractions, you can cross simplify. So there's 1 9 here and 1 9 here, right? And in that case, you end up with 1 times x over 1, which is just x over 1, and x divided by 1 is just x. So everything over here on the left cancels except for the x. And that is why we do the opposite, to cancel stuff out. And in this case, it equals -72, because that's what -8 times 9 is. And that makes sense. You know, -72 divided by 9 is -8. So we're making progress here. All right, one more example, but here's your number clue. It is a multiple of 8. All right, last example. When you're dealing with fractions, you think of them the same way as numbers. So this right here is just one big number. It's just 2/3. This is just 2/9. So we're not going to do anything different or fancy. We're going to do what we've been doing. We're going to determine what's going on to x. Well, in this case, 2/3 is being multiplied by x. So I have to divide both sides by 2/3, because the opposite of multiplication is division. So I'm going to divide both sides by 2/3. Okay? And 2/3 divided by 2/3 is 1, and 1 times x is x. So they cancel. So x is going to equal whatever 2/9 divided by 2/3 is. And if you remember, you keep, and then change, and then flip. Keep, change, flip, right? And then you can figure it out. I'm going to cross simplify here first. And okay. So I end up with 1/3. So x must be 1/3. And if I was to plug that in, for x, if I was to put in 1/3 for x here, 2 times a 1/3 is indeed 2/9. So I know that that works. Now I'm not going to take the time to review fraction, multiplication, and division because you guys already know it. But if somebody in the room or in the class forgot how to do it, please don't be shy. Don't feel bad. Just ask for help, because I want you to know how to do it. It's just I don't want to explain it all in the video and make the people who remember get bored. So anyways, that's all there is to it, guys. Identify what's going on to x, do the opposite, solve for x. Good luck.